Assalamu alaikum, everyone. Welcome to Mathematics with Shahab Yaqub. So, now this is lecture number 6 of normal distribution, in which we'll be doing some more past paper questions. Let's look at the first question. It says the weights of letter posted by a certain business are normally distributed with mean 20 grams. It is found that weights of 94% of these letters are within 12 grams of the mean. Find the standard deviation. Now, very first thing is to grab this normal distribution curve. Let's paste it over here. And I'm focusing on the first part. X follows a normal distribution. The mean is 20. Standard deviation is sigma. We write sigma square inside the bracket. 94% are within 12 grams of the mean. So let me highlight it. Let me draw a line over here. Let me draw a line over here. Let me draw a line in the middle. This is 20 grams. This is 20 plus 12, 32. This is 20 minus 12, which is 8. And then it says 94% are within 12 grams of the mean. That means this is 94%. It is symmetric. Therefore, 3% on the right over here, 3% on the left over here. That means probability X less than 32 is 94 plus 3%, 97%. That is the working that needs to be done. I hope it's loud and clear. Probability X lesser than 32 is 0.97. Make sure the probability is at least 0.5 and there is a lesser sign. Z value will be positive. So let me write over here, Z value will be positive. And probability Z is lesser than 32 minus 20 divided by sigma, that is 0.97. Probability Z is lesser than a positive value is 0.97. Let me go to the main table and let me locate 0.97. So 0.97, this is 9699. I think that could do the job, but no, we have to add it. And then there is this one. So this is 1.88 and then 1. Now, if someone says there is another one also, yes, that is also acceptable. 2 is also acceptable. So let me use 1.881. So therefore, the Z value is 1.881. So therefore, 12 over sigma is 1.881. 12 over 1.881 is sigma. Use a calculator, find the value of sigma, and then you will get the answer. So let me look at the first working. They have written both of them. And then sigma is coming out to be 6.38. So sigma is coming out to be 6.38, correct to 3 significant figures. That's a rounded off value. And let me also write the unrounded value. So therefore, 12 divided by 1.881, this is coming out to be 6.379. So therefore, sigma is coming out to be 6.3795. So 3795, I can write it like this, and then it becomes 6.38. All good, all clear. Let me copy this thing, take it on the next page. And let me focus on the second one. It says find the probability randomly chosen letter weighs more than 13 grams. This is simple. We will write second part. X follows a normal distribution, 20 comma, use the unrounded value, 6.3795. Let me write it over here. 6.3795 square and more than 13 grams. Probability X is greater than 13. Probability Z is greater than 13 minus 20 divided by 6.3795. Probability Z is greater than a negative value, whatever that value is. 7 divided by 6.3795. So let me reciprocate it, multiply it with 7. That is 1.09725. 1.09725. So let me write this thing as 7 because for Z, the maximum you can go is 3 dp. So Z greater than a negative value by symmetry is the same thing as Z lesser than a positive value. So just read directly 1.097. So now we are going to, this is 1.0 and then 9 and then 7. So this is under 7. So 8621 plus 16, 27, 37, 86, 37. So this is 0.8637. That can be written as 0.864, correct to 3 significant figures. Double check the answer, 0.864, that's all good. Now, there is also a third part. So each part is taking a lot of space. And I'm also writing with gaps in it. Now, let's focus on this, the third part. It says find the probability at least two of a random sample of 7 letters have weights which are more than 12 grams above the mean. Now keep that in mind. This is more than, and this is within 12 grams of the mean. So now if I go to the same diagram over here, this is more than 12 grams above the mean. So this is 3%. Okay. So now let me write it out. X follows a binomial distribution. So basically, the probability of success was obtained from the information given for normal distribution. And it was related with part 1, with the diagram. So now over here, I'll write 7. That's the number of trials, and 0.03. More than 12 grams above the mean. So probability at least 2. X is greater than or equal to 2. So if I draw a number line, that would be this thing. That would be 0, 1, 2, 3, all the way till 7. So they're asking for greater than or equal to 2. That's so many of them. What's the shortcut? Calculate the probability for 0 and 1 and subtract. 1 minus probability X is lesser than or equal to 1. This is 1 minus 7C0 and then 2 brackets and 7C1 and then 2 brackets. And what goes inside the bracket? Probability of success 0.03, 0.03, power 0, power 1. Probability of failure 0.97, power 7, power 6. This is 0.97. And then, of course, you should write down this value. You should write down this value, add it up, and then subtract from 1, and then you get the answer. So the answer, it's right over here, all this thing, that is 0.0171. So this is 0.0171, correct to 3 significant figures. That is the answer right over here. So this was binomial. The last part was binomial. The probability of success was given from the information of normal distribution. So now this thing is done and dusted. And let me also copy this thing because maybe in some parts the thing might not be there. Let me just double check. I think I would be needing in this one. Okay, so let me put it somewhere in the middle over here. And it goes like this. Okay, so let's go back up. Now this thing is done. Let's focus on this question. Why don't you read the question first? and then I'll start in a minute. Now it says the lengths in centimeter of trout in a fish farm are normally distributed. 96% of the length are less than 34.1, 70% of the length are more than 26.7. Find the mean and standard deviation of the length of the trouts. So now I think I'll be needing naturally another page also. So let me also add it over here. Okay. Now the first thing I'll write for part one, X follows a normal distribution, mu, comma, sigma square. 96% are less than 34.1. Probability X less than 34.1 is 0.96. 70% are more than 26.7. Probability X greater than, more than 26.7 is 70%. Now focus on the signs. There is a lesser sign over here, Z value will be positive. There is a greater sign over here, Z value will be negative. Both probabilities are up to the mark. They are both more than 50%. So that's not an issue. So now let me focus on two things. That is, if the probability is 96%, what is the Z value? If the probability is 70%, what is the Z value? So 0.96, let me first locate it. So now 0.96, 0.96, this is 9599. There is this one over here. This is 1.75 and 1.75. And similarly, 0.70, 0.70 is 706985. 6985, that is 0.5, not 3.52, and you need 15 more. So I think 14 is good enough. So let's use this. So 1.751, let me first write it. So this is the red one, 1.751. And then the blue one, that is 0.524. So this is the blue one. Okay, 1.751, 0.524. 1.751, 1 point, let me write over here, 1.751, and this one is 0.524 with a negative sign. Now let me fill in the rest. So now over here, probability Z is lesser than 34.1 minus mu divided by sigma is 0.96. Probability Z is lesser than a positive value is 0.96. Probability Z is greater than 26.7 minus mu divided by sigma is 0.70. Probability Z is greater than a negative value is 0.70. So 34.1 minus mu over sigma is 1.751. In other words, 34.1 minus mu over 1.751 is sigma. 26.7 minus mu divided by sigma is negative 0.524. 26.7 minus mu over 0.524 with a negative sign is mu. Equate the two, 34.1 minus mu divided by 1.751, that is 26.7 minus mu divided by negative 0.524. And then you simplify, you'll find the value of mu, and then you'll find the value of sigma. Just focus on the working on that particular equation. If this equation is all good, all clear. That's one equation. And this is the other equation. 34.1 minus mu over sigma. 34.1 minus mu over sigma is 1.751. That is good. 26.7 over sigma is negative. This is good. And now the values are over here. 28.4, and 3.25. That's all good. Okay, let's move on. The next part. In another fish farm. So now we are not interested in the previous one. So can we go ahead and crop it out? So now let me do this. And then it says in another fish farm, the length of salmon are normally distributed with mean 32.9 and standard deviation 2.4. Find the probability a randomly chosen salmon is 34 centimeter long, correct to the nearest centimeter. Now, this is totally brand new because in normal distribution, we are used to a range. So over here, what will help us? The lower bound and the upper bound of O-level math will help us. It's not about normal approximation. It's just about the nearest thing. That means we can say that y follows a normal distribution 32.9, 2.4 square, and probability y lies between the upper bound and the lower bound. That is 33.5 and 34.5. Don't worry about the inequality because it's by default inclusive. So now I'll standardize probability 33.5 minus 32.9 divided by 2.4. And this is 34.5 minus 32.9 divided by 2.4. It lies between two values. And then probability z lies between this one is a positive value. This one is also a positive value. So z lies between two positive values. And what are those positive values? Let me write it down. One of them value, the 34.5 value, that is 667 and 0.25. So let me just share this mark scheme with you people also. And where is it? That's the share thing. Okay. Okay. So I'll just share in a bit. Let me just write down these values. So this is 0.667. So this one is 0.667. The small one is 0.25. This is rule number 5, pi of 0.667. That means read the table for this value, read the table for 0.25. Now, if you read the table, this is 0.7477. Probability is written in 4 decimals because that's how it's given. This is 0.5987, and this comes out to be 0.149. And that is the answer, correct to 3 significant figures. So that is the new thing, that when it's an equal thing, so salmon is 34 centimeter long, use the upper bound and the lower bound, it should lie between that particular value. So let me copy this thing and add a new page over here. Okay. Now the last part. Find the value of t such that probability x lying between 31.8 and t is 0.5. Now, this is another fish farm. This has nothing to do with the first fish farm. Just double checking because look at the question. This goes like this. So this goes like this. So this paragraph is related with this and this. This first paragraph is related with this. Okay. So now, first thing first, what needs to be done? If I draw a number line, I think a number line is good enough rather than a curve. So now this is 31.8. The mean is 32.9. That's somewhere over here. There is t over here. And they are saying this is like 50%. So let me calculate the probability lesser than 31.8. So if I have this probability lesser than 31.8, then I can have a total probability with respect to t. This is just like that SOAP question that we did in class. Okay. So now first thing first, part 3. That is, so now write this down. Y follows a normal distribution 32.9 comma 2.4 square. Probability y is lesser than 31.8. Probability Z is lesser than 31.8 minus 32.9 divided by 2.4. Probability Z is lesser than a negative value. So let me first write down this value. How much is this? So this is 31.8 minus 32.9 divided by 2.4. This is coming out to be 0.458. So this is 0.458 rounded off correct to 3dp. So Z lesser than a negative value, Z greater than this same positive value because of symmetry. That is indirect reading. 1 minus probability Z is lesser than 0.458. That is 1 minus this particular value, 0.458. So let me go over here, 0.458. That is the Z value. This is 0.4. This is 5. And this is 8. That's right over here. Okay. So that is 6736 plus 29. So this is, let me write over here, 6736, and this is 29. Let me double check. Yes. So this is 6736 plus 29. That comes out to be 6765. So this is 6765. 1 minus 0.6765 divided by 1, 2, 3, 4 minus 1. That comes out to be 3235. This is 0.3235. Okay. That is lesser than this thing. So this is 0.3235. So now add it up. Probability x lesser than t is 0.3235 plus 0.5. How much is that? So 0.3235 plus 0.5, that is 0.8235. So this is 0.8235. This is the probability value. Find the corresponding Z value. 8235. So now 8235, 8238, 8212. 8212 is 0.9. This is 2 and 35. So I need 23 more. Okay, there it is. Okay, so this is 0.929. 0.929. So now the Z value is 0.929. Keep it handy. So now probability Z is lesser than T minus, how much is the mean? 32.9 over 2.4. 32.9 over 2.4 is 0.8235. This is back solving. Probability Z lesser than some value is 0.8235. How much is this value? 0.929. So T minus 32.9 over 2.4 is 0.929. So 0.929 into 2.4 and then add to it 32.9. That comes out to be 35.1296. T is 35.1296. And write this thing as 35.1, correct to 3 significant figures. Let's double check the working. And this is 35.1. Now look over here. They have done this thing in a slightly different way, if I use very soft words for it. So the way that I have worked out using number line, that is straightforward. Yes, they have given you 4 marks. So of course, first of all, you have to use one of the basic rules. First, find probability. So this is first find probability and then use number line and then use back solving to find the answer. So that question that we did earlier, the soap question, half of it was already done. So now in this particular question, yes, this was new that we solved earlier. And both parts are given for 4 marks, which is a little bit less for this. But now, not always life is fair. So that is how this particular question is done and dusted. Okay, now let's look at this question. So now let me just go to the WhatsApp. And this thing is the question about the salmon, I think. Yeah. So now the question about salmon, the new thing plus the number line. Once again, I hope this is all good, all clear. So this thing is there, AS1 and AS2. Okay. Now, someone asked me the request that can you explain the third part again? Sure. It says, find the value of t such that x between these two values is 50%. There is this value, there is this value, this is 50%. So now the way that I have taught you back solving, that is only for single values. So I have 31.8. Let me calculate this probability. Probability y lesser than 31.8, y or x, whichever symbol you want to use. You standardize, you read off the value, that comes out to be approximately 32%. So lesser is 32%. Between t and this thing is 31.8. So all the way lesser than t. So let me draw a number line over here. All the way lesser than t is 0.8235. So that is the working over here. Probability x lesser than t is 0.8235. And then it's back solving. And then this is going to the table, reading of the c value, and so on. So I hope it's all got all clear. And just let me write y instead of x. So now this is good. Let's move on. Question number 71. Read this question first. It says a farmer finds that the weight, let me get this thing ready. The weight of sheep on his farm have a normal distribution. Okay, hold for a second. Okay, all good. Have a normal distribution with mean 66.4 and standard deviation this much. So that's the mean, that is the standard deviation. 250 sheep are chosen at random. Estimate the number of sheep which have a weight between 70 and 72.5. That is easy, but don't forget that this is estimation. The second thing, that is this thing, the proportion of sheep means the same thing as probability, percentage. Weighing less than 59.2 kg is equal to the proportion weighing more than y kg. Find the value of y. This is 2 mark. This is slightly tricky. And then the third part is there. So let me just copy this and take to the next page. And let me crop this thing. Over here. Okay, and over here, I can even crop this thing like this. Okay. Okay, all good. So now let's start with the first part. Now, the first part, that is part one. We will say that x follows a normal distribution, 66.4, 5.6 square. Weight between 70 and 72.5. Probability, x lies between 72 and 70 and 72.5. Probability, this is 70 minus 66.4 divided by 5.6. This is z. 72.5 minus 66.4 divided by 5.6. 2.4, I think, was in the previous one. Probability, z, lying between two values. And I can simply quote it from the result where it is. Okay, again, this is one of the value is 0.6429, 1.089, 6429, 1089, 6429, 1.089, and this is 0.6429. Now, both these z values are positive. Phi of 1.089 minus phi of 0.6429. Let me go to the table. 1.089. So this is 1.089, 1.0, and then 8, and then a 9. 8599, that would make it 8600, 8620. So let me first write it over here. That is 0.8620. Let me go to the other value, that is 6429. 64, that is this thing, and 6429, so 643. 643 would do the job. So therefore 7389, 7399. So this is 0.7399, and the value that I read off was 0.643 because that is 3 decimal places. So now let's subtract. Let me grab my calculator. That is 8620 minus 7399. That comes out to be 1221.1221. Now, do not round off at the moment. Expectation, that is how many sheeps were taken? 250. So let's take 250 sheeps. Let's multiply it with 0.1221 into 250 divided by 100. That is 305.25. That is 305.25. Both answers are acceptable. Round up or round down. Round down 305. Round up 306. No harm in double checking. 30 point. My bad. I think I missed a decimal. There were 250. So I think that is 30.52. So let me first write this thing. 30.526.525. Therefore, round up 31, round down 30, both are acceptable. So therefore, this is 30 or 31 sheeps. That's how it's done. Now let's focus on the next part, the second part. It says the proportion of sheep weighing less than 59.2 is equal to the proportion weighing more than Y. Now this question is all about symmetry. What is the mean? The mean is 66.4. This is 66.4. This is 59.2. This is Y. Weighing less than 59.2 is the same thing as weighing more than Y. In other words, there has to be a symmetry over here. So there are two ways of solving this thing. Method one, find the difference. The difference between these two should be the same thing as the difference between these two. So 66.4 minus 59.2 should be the same thing as Y minus 66.4. So 66.4 and 59.2. So 66.4 minus 59.2, that is 7.2. This is 7.2 is Y minus 66.4. Add to it 66.4. Therefore, this is 73.6. That's one way of doing it. What is the other way of doing it? That is the midpoint formula. Method 2, that is the midpoint formula. So basically, this is the midpoint between these two. So 66.4 is half of 59.2 and Y. Half of 59.2 and Y is 66.4. So 66.4 into 2, that is 132.8. And this is 59.2 plus Y minus 59.2. Therefore, Y is 73.6. So a very nice question, something related with symmetry. This is also brand new, but based upon symmetry. So I hope this is all good, all clear. Let me write it over here. So the sheep question, and it's about the new thing is about symmetry. Okay, so sheep symmetry, I think this is all good. So AS2, AS1, all good. Let's move on. Now, over here, let's look at this question. Another farmer finds that the weight of sheep on his farm have a normal distribution. This is just the basic thing, nothing special. Now, this is Y follows a normal distribution. The mean is mu, and the standard deviation is 4.92. Put a square over here. 25% weighing more than 67.5 kg. So probability Y greater than 67.5 is 0.25. What is the issue over here? The issue over here is this probability is lesser than 50%. Flip, subtract the probability from 1. Y lesser than 67.5 is 0.75. Probability Z is lesser than 67.5 minus mu divided by 4.92 is 0.75. Probability Z is lesser than something is 0.75. Go to the table, go to the strip. For 0.75, this is the Z value, that is 0.674. So this is 0.674, and because of the lesser sign, this is positive. So 67.5 minus mu divided by 4.92 is 0.674, and 67.5 minus mu is 0.674 into 4.92. Therefore, make mu the subject. 67.5 minus bracket 0.674 into 4.92. And then you can, of course, use the calculator and you can get this answer. So mu comes out to be this thing, 64.2. So mu comes out to be 64.2. That is the answer, correct to 3 significant figures, which is the standard rule. So I hope this is all done and dusted. Okay, now let's look at this question. Let's read it. And then there are 3 parts to it. We'll be doing every single part. Now, let's read the question. The first question. Farmer Jones grows apples. So now our story of normal distribution started with apples and it's ending on apples. For right now, it's about apples. The weights of apples grown this year are normally distributed with mean 170 and standard deviation 25. Apples weighing between 142 and 205 are sold to the supermarket. First part, find the probability that a randomly chosen apple grown this year is sold to the supermarket. So let's just focus our attention only to the first part. Let x be the variable. X follows the normal distribution, that is the weight of the apple, a 170 and 25 square. So 170 and 25 square. And it's between 142 and 205. Probability x lies between 142 and 205. This is part A. Standardize probability Z lying between 205 minus 170 divided by 25. 142 minus 170 divided by 25. Probability Z lying between two values. Let me get those values. Also, people, grab your calculator and evaluate. 205 minus 170 divided by 25. This comes out to be exact 1.4 positive. And 142 minus 170 divided by 25. That comes out to be negative 1.12. Negative 1.12. This is rule number 7. Read the table for 1.12. Of course, you will discard the negative sign. Read the table 1.4 and add the probability, subtract 1. So phi of 1.12, phi of 1.4 minus 1. So 1.12, let me go over here, and 1.1 and then a 2. Okay. So that is 8686. So let me write over here. That is 0.8686. 1.4. 1.4 is just this value, 9192. That's 0.9192. So let me add it up. 0.9192 plus 0.8686, and then subtract 1, and this is 7878. First write the value as it is. This is 4SF, and then write this thing as 0.788, correct to 3SF. So that is the answer for the first part. Now let's move to the second part. So it's already pasted over here. Now it says this Farmer Jones, sells the apples to the supermarket at $0.24 each. He sells apples that weigh more than 205 grams to a local shop at 0.30. So more than 205 at 0.30 each. And then he does not sell apples that weigh less than 142 grams. Achha. The total number of apples sold by this farmer is 20,000. Calculate an estimate for his total income. So now this is like everyday maths and action. So now he sells the apples to the supermarket at 0.24 each. He sells apple that weigh more than 205 at 0.30 each. So now we have done a little bit of the working. Probability. First of all, let me write this thing. Y follows, or X follows a normal distribution. X follows a normal distribution that is 142 and 20, sorry, that is 170 and 25 square, 170 and 25 square. Probability X is greater than 205. Let me calculate this probability. Probability X greater than 205, we already got the Z value. That's right over here. Z greater than, that's right over here for 205. This is 1.4 and this is the probability, 0.9192. So this is Z greater than 1.4, which is 1 minus probability Z lesser than 1.4. This is 1 minus 0.9192. Let me do the subtraction. So I don't have to go to the table once again because the value was already written there. Got it? 0.0808. 0.08, nice number. That is 0.8. That's the first thing. Now, we know that the others are sold probability X between 142 and 205. This answer came in the first part. That was 0.788. So this answer is 0.788. Actually, 78 and the unrounded. 7878. This is 7878. Got it? Now, let me draw a number line and let me just do a bit of adjustment. Okay, so now let me just remove this thing. There's no need. Let me take this thing and put it downstairs like this. And let me draw a number line over here. Now, there are three values. There are two values that are of importance to us. One is 142, the other one is 205. This is 142. This is 205. Greater than 205, let me highlight it. That is this thing. So greater than 205 is 0.0808. That is this thing. Between 142 and 205, that is this blue thing. Between 142 and 205, that is 7878. That is this thing. So now let me write over here 0.7878, and greater than 205, this thing is how much? 0.0808, a very small percentage. And lesser than 142, that is of no use because they are not sold. Okay. And no money is brought, that is incoming from that. So now if I draw a table and like this and calculating the expected value, So this is a question of expectation. So now we have X and we have the probability. So if the probability more than this thing, that is how much? 0.24, and more than 205 is 0.30. Cells. So 0.30, that is being sold at 0.0808. And the rest are sold at 0.24. That is this percentage, 0.7878. Got this thing? It's a very nice question. Probabilities are taken from the normal distribution. Greater than 205 is this much. Weighing more than 205 is sold at 0.30. So what is the probability? 0.0808. Between these two, he does not sell apple weighing less than 142. So this is no use of writing it. And the rest of the apples are 0.24 each. Calculate an estimate for his total income. So now his cost price is this much. So therefore, this is 0.24 into this value, 0.7878. And even before that, let me do one thing. That is this percentage of 20,000. So 0.7878 of 20,000 apples is how much? How many apples are there? And 0.0808 of 20,000, how many apples are this? Let me first calculate. So therefore, into 20,000, that is 1616. This is this thing, 1616. And this thing, 0.7878 of 20,000, this is 15,756. 15,756. And if I add these two, 1616, that is this much minus 20,000. So now 2628 apples were not sold. So this is not sold, so just discard it. What is the question? How much is the total income? So now the total income will go like this. So this value over here, 0.24, this value is for this percentage, is for this many apples. So 15,756 into 0.24. That is the income in dollars. And then over here, this value 0.30, that is 0.808, that is for this value. So therefore, 0.30 into how much? That is 1616. And that is what we are calculating. So now 1616 into zero point 0.3, that is 484.8. 484.8, a very tricky question. And then this one, 15,756 into 0.24. Okay, that is 3781.44. 3781.44. Therefore, the total income that this person is getting plus 484.8, 484.8, and this is coming out to be 4266.24. If they have not mentioned anything, I think I'll just write the exact value. Part B, let's double check the answer. So part A was this thing, part B 4266.24. 4266.24. This is exact. So give yourself a star. So that is how this particular question is done. Of course, the last part is left. And let me just crop this thing because I just need the very last part. There is another farmer. The first one was June, and this one is this person, Dan. This person also grows apple. The weights follow a normal distribution such and such. So Y follows a normal distribution, 182, 20 square. 72% have a weight more than W. So probability Y greater than a small w is 0.72. This is more than 50%, all good. So go to the table for 72%. So 71, 71, 71, 90. This is corresponding to 0.58, and 10 falls under 3. So that is 0.583. So that is what we are getting. So Z value is 0.583. And then you would write that probability Z is greater than W minus 182 divided by 20 is 0.72. Probability Z is greater than 0.583 with a negative sign because of the greater sign as 0.72. W minus 182 over 20 is negative 0.583. Make W the subject, that is negative 0.583 into 20 plus 182. So 0.583 into 20 minus 182, this comes out to be 170.34. So W is 170.34, and I can round it off 170 correct to 3 SF. As such, I think if you even write this thing, that is all good. So let's double check 170. Yes, they have given the answer correct to 3 SF. So we have done lots of questions related to normal distribution. And this was lecture number 6. Lecture number 7 was done in class. So it's all done and dusted. So chapter is all over. Stay tuned for more content on mathematics with Shah Yaqub.